Okay, we're back to go over EDay 4 exit slip. Let's take a look at number 1. So we have to calculate the lateral and total surface area of each right cone or regular pyramid. So we know that if it has a polygonal base, it's going to be a regular polygon, which is exactly what we see happening in number 1. Number 1's pyramid is a hexagon. And so since the direction told us that all of these are regular pyramids, that means this is a regular hexagon. So if it has a side length of 8, that means all of the sides have a side length of 8. So all 6 sides have a side length of 8 centimeters. So its perimeter is 48. As far as the area of the base goes, it's going to be the shortcut formula for area of a regular hexagon. There are 6 equilateral triangles, and so each of those equilateral triangles has a side length of 8, so 6 times side squared root 3 over 4, same as 6 times 8 squared root 3 over 4, which reduces to 96 root 3. So now we have the perimeter of our base and the area of our base, which is going to help us because the surface area of a pyramid, there is one base that we have to paint, and then there is all of the lateral faces, 1/2 PL. So we put our parentheses in, we have our B and our P, and then of course our slant height. So these values for B and P go in their corresponding spot. So area of the base is 96 root 3. Perimeter of our base is 48, so we can plug those in. The slant height is the only one that we have to go back into the original diagram to look at. Now, fortunately for us, they gave us the slant height. Remember, the slant height goes from the top vertex. It goes perpendicular to the midpoint of one of the sides of the base, and so this 12 is our slant height. So we're just going to plug that right in to here at the last spot in our formula, and then compute. So the 96 root 3 will stay by itself. When we multiply 1/2 times 48 times 12, we get 288. So altogether, since the root 3 and the 288, we can't combine those, we're going to keep them separate. 96 root 3 plus 288. And our units are centimeters, so square centimeters. To get our lateral area, we just go back. We do not include the base. Everything else, though, our lateral area is 288 square centimeters. And I forgot to write down the name. We talked about this being a regular hexagonal pyramid because there's only one base. All right, so that was number 1. Let's take a look at number 2. So here we have one base, and this time the base is a circle. So as far as our circle goes, the main thing we need to make sure we know is what the radius is. So here the radius is, I have to look at the diagram here. The radius is part of a right triangle with the altitude or the height of the cone, the slant height of the cone, and the radius. So they're telling us that the height of the cone is 24. That's what this little arrow is. And then since this slant height is 25, this one is also 25. So I'm just going to cross that out because it's kind of confusing. So here we actually have a Pythagorean triple. It's a 7, 24, 25. So we get that our radius is 7. And again, our slant height is 25. That's going to be useful in a second when we need our slant height. So with our cone, we start off with our regular pyramid surface area formula, so B plus 1/2 PL. But then we plug in our circle formula, so pi r squared for the base, perimeter is 2 pi r, and then slant height. Now 1/2 times 2 multiplied together is equal to 1. So the formula we use, the simplified formula, is pi r squared plus pi r l. Okay, so I'm just going to shrink this middle work here down. Really, all we need to worry about now is this pi r squared plus pi r l, with the two variables that are really important being the radius and the slant height. So we already know that the radius is 7, and we already identified in our diagram that the slant height is 25. They gave that to us over here, so we can plug that in our formula, and now we just have to multiply. So here we're going to have the surface area is 49 pi. 7 times 25 gives us 175 pi. So we can combine those together since they're both like terms. The 175 plus the 49 gives us 224 pi. So that's our total surface area for this cone. 224 pi, and our units are inches, so square inches. We can go back into our work to find the lateral area. This here is our lateral area. So we have 175 pi square inches. All right, so there was two quick examples, one for a pyramid, one for a cone, slight variation between the two. Let's try the next one. So this one wants us to work backwards. They want us to find the slant height given the surface area. So like I said, we have to start with what we know. They're telling us that the surface area of a cone. So our formula for surface area of a cone is pi r squared plus pi rl. And that total surface area is 120 pi. And they're telling us that the radius is 8. So wherever I see the r, I'm going to plug in 8. And they want us to solve for the slant height. So I'll just leave that as L. So here I'm just going to do some basic algebra. This is 64 pi plus 8 pi times L, this stays together, is equal to 120 pi. So I'm going to subtract the 64 over from both sides and get 56 pi is equal to 8 pi L. I'll keep it color-coded. From here, we want to isolate that slant height, that L. So I'm going to divide both sides by 8 pi. And when I do that, these cancel. The pi's cancel on the left. 56 divided by 8 is, let me just shrink this so I can fit it all in the same spot. 56 divided by 8 is 7. So the slant height is 7 meters. All right, so we just had to work backwards using the formula, plugging in what they give us. All right, and the last one, we have a composite figure. So again, with surface area, we're asking ourselves, what do we have to paint in this figure? So we're going to go fit shape by shape. So I see a cone up here, a cylinder, and then another cone. So I have our cone, our middle cylinder, and then our other cone. Okay, setting up my plan of attack here. When I look at that top cone, cone number 1, I'm asking myself, am I painting the entire surface area? Am I painting the base and the lateral area, or just one of the two? Well, since this cone is being stacked, this bottom base will not be painted, so we're not going to include it. All we want from the total surface area formula of a cone is the lateral area part. So we just want the lateral area of the cone, which is pi rl. Okay, we're not painting the base, so we don't include the pi r squared. Okay, next we look at the cylinder. So for the cylinder, we have the two bases, and then we have the lateral area. Because, again, the cylinder is being stacked, there's something stacked on top and on bottom, we don't include those two bases. We're only going to include the lateral area of that cylinder. So remember, it's 2 pi r squared plus 2 pi rh is our formula. We are not including the two bases, just the lateral area, which is 2 pi rh. Using the same thought process, we look down at cone number 3. Down below, its base is being stacked on top too, so it's being covered. We will not include that base. So just like the first cone, we just want the lateral area, which is pi rl. Okay, so now that we have our plan down, we know what we're looking for. Now we have to go back into the diagram and find all of the dimensions. Now, since all the bases of all three of these shapes are the same, they're all going to have the same radius, which is this 12 meters. So wherever we see the R, it's going to be 12. So I'm going to have a 12 here for our radius, here, and here. So I'm just going to go ahead and start putting in my parentheses so I know what I need to find. 2 pi r h plus pi r l. All right, so we know all of our radii. Now let's get our slant height. So in this first cone, the slant height they give us is 26. So I'm going to plug that right into the slant height here, 26. So this is our slant height for the top cone. For the cylinder, we need the height of the cylinder, the distance between the two circles, and that distance they're telling us is 15. So this is going to be the height of the cylinder. And then the last value that they're asking for is, I'll do it in yellow, is the slant height of the last cone, which again, luckily they give us is 32. So I'm just going to plug that right in. So this is the slant height, 32 over here. So now I have all of my values plugged in. It's super organized and clear and obvious where I'm getting all of my numbers. Everything's labeled. So now I can just go one at a time, multiply through, and then add them all together. So here's going to be 12 times 26 times pi is 312 pi. 2 times 12 times 15 is 360 pi. And then plus 384 pi, and then we just simply add them all together. Because they're all three like terms, we can combine them and get 1056 pi square meters. So our total surface area, 1556 pi square meters. All right, guys, hope that makes sense. Let us know if you have any questions.